Hello, my name is Alex Booker, and in this presentation, I'm going to introduce you to JavaScript arrow functions. Arrow functions serve two main purposes. Firstly, they afford an alternative, more concise syntax for defining functions, which can improve the readability of your code in certain scenarios. Additionally, and perhaps more importantly, arrow functions make the this keyword behave more intuitively in certain situations via something called lexical binding. Now, I'm going to talk more about how arrow functions tackle the this keyword towards the end of this presentation. First though, I want to illustrate for you what an arrow function looks like as compared to a traditional function expression. This here is a traditional function expression that's probably familiar to you. And this is an arrow function expression which is new in ES.6. In both cases, we assign a function to a variable called square. We can then call either function via the square variable, and in this particular case, they'll return the same value for the same input. Now, whilst arrow functions aren't always equivalent to traditional functions, in this case, these two functions are fundamentally the same. It's just that the arrow function on the right-hand side is much more concise. Let's take a closer look at the arrow function syntax. What you're looking at here is the same square arrow function from the previous slide, just zoomed in. It consists of a single parameter called num, followed by an arrow that gives these functions their name. What follows the arrow is an expression whose result is implicitly returned when the function is called. So when the square function is called with a number, the result of the expression num times num is automatically returned. There's no need for a return statement because JavaScript can infer that you want to return the result of the expression. Now, arrow functions actually come in a variety of slightly different syntaxes. In this case, we have an arrow function that takes a single argument whose body is a single expression, but it's actually possible for an arrow function to take more than one argument. Just know that when the function has multiple parameters, like this one, you need to surround the parameter list in parentheses. It's also possible, by the way, for an arrow function to take 0 arguments. To signify that the function takes no arguments, you need an empty pair of parentheses like this. Now, if your function needs a statement, like an if statement, or maybe it needs a variable declaration, you need to make the arrow function's body a block statement instead of a single expression. This really isn't too much different from a traditional function expression. Just remember that within a block statement, if you need to return a value, as we do here, you need to do so explicitly using a return statement. If all of this breaks your brain a little bit, then don't worry about it. My goal here is to just give you a general feel for what arrow functions are all about. Let's try and solidify this information with a demo. To demonstrate arrow functions, I'm going to use an online tool called JSBin. You can find it at jsbin.com if you want to follow along. We're only going to be looking at JavaScript code and console outputs in this demo, so I'm going to enable those panels and disable the rest. Because arrow functions are an ES6 feature, I'm going to select ES6 from the JavaScript dropdown. Okay, now JSBin is all set up, I can begin to show you arrow functions in action. What I'm going to do to illustrate arrow functions is take the already familiar square function that you've seen throughout this slide deck, and I'm going to refactor it to become an arrow function. Before I do that, I just want to point out really quickly that beneath the function definition, I'm calling the square function with the number 10 and immediately writing the result to the console. If I want to see the output, I can press run in the top right corner here, and the output will appear in the right hand pane. I want you to be able to compare the function before and after we refactor it. So I'm going to copy the original function, comment it, and then paste the copy down below. Okay, so let's convert this function into an arrow function step by step. First of all, we can remove the function keyword before the parameter list and replace it with an arrow after the parameter list. Now, in all actuality, these are two separate symbols, an equal symbol followed by a greater than symbol, but combined they're colloquially referred to as an arrow. Now, if we run this code, you'll see that it actually works. And the reason why it works is because, like we touched on in the previous slide, it's possible for an arrow function's body to be a block statement, as is the case here. However, in this particular case, we can optimize the function further. For one thing, we can remove the return statement because it's possible for JavaScript to infer that you want to return the result of this expression, so JavaScript automatically returns the result of the expression. Also, because there's no longer a return statement, it doesn't really make sense to have a block statement, which traditionally groups statements. And with an arrow function, all the code has to be on the same line. So I'll put that all on the same line and run the code. And as you can see, everything works fine. There's actually one more optimization we can do here, which is to remove the parentheses surrounding the only parameter, because when an arrow function only has a single parameter, the parentheses are optional. Now, in this particular case, we assign the arrow function to a variable called square. But just like with traditional function expressions, it's possible to pass arrow functions as arguments to existing functions. Let's take a look at that now. In my clipboard, I have a little snippet of code that basically takes an array of numbers and then squares every number in that array. If I run the code, you can see that every number in the original array has been squared. In this snippet of code, I call the map function on the numbers array and pass to the map function a traditional function expression. Whether or not you're familiar with how the map function works or not, it doesn't really matter. What I really want to draw your attention to is the fact that I'm passing a function expression as an argument. And when you see code like this, and it's a common pattern in JavaScript to pass a short little function to arguments, you have yourself a prime candidate for an arrow function. Let's convert this traditional function expression into an arrow function. We'll see how much more expressive it makes our code. This is the same conversion we did before, so I shan't belabor it too much. We'll remove the function keyword and replace it with an arrow after the parameter list. While I'm up here, I'll also remove the superfluous parentheses surrounding the only parameter. Within the block statements, I'll remove the return statement, and then eventually I'll also remove the block statement itself. If I run this code, you can see that we get the same exact output as we did previously. That's because in this particular case, the arrow function is just an alternative, more concise way to express the same thing. So we've seen how arrow functions afford us a more concise syntax for defining functions, but arrow functions are actually more than just syntactic sugar because they also have a positive impact on the this keyword. Let's look at an example. This is a really basic constructor function called person. It takes a name argument and then immediately sets that name on this. Then, within a contrived callback function, we log the value of this.name. Now tell me, what do you think this line will write to the console? Well, the intuitive answer would be Alex because we set this.name to the argument name, which is Alex. But actually, depending on where you run this code, this function will probably print undefined. Basically, when you create a new function like we do here, that new function gets its own this value that is set dynamically depending on how the function was called. Suffice to say, the outer and inner this keywords do not reference the same object and therefore their name properties are different. And it can be super confusing and it trips up even experienced developers. When you really need to reference the outer this value, as you often do, you have to resort to hacky solutions like this one, where you set var that equals this, and then instead of referring to this, you refer to that within the nested function. It's an ugly hack, honestly, but as you might have ascertained by now, arrow functions solve this pain point. As you can see, I've made the nested function an arrow function. Now if I ask what this function will print, if you were to say the intuitive answer, Alex, you'd be right. So what's changed? Well, a function's this keyword value is usually bound dynamically depending on a few factors I won't get into. Arrow functions, on the other hand, are bound lexically. That might sound complicated, but all it really means is that the this keyword's value is always going to be the same inside the arrow function as it is outside. So if you ever find yourself writing that equals this, or maybe using the bind function, which is another less than ideal workaround, consider using an arrow function instead. I hope by watching this video you now know enough to start using arrow functions out in the wild. What I hope you take away from this video is that arrow functions are largely a syntactic nicety that can improve the readability of your code, but they also make the this keyword behave more intuitively, which in turn also contributes to readability. I hope you're really excited about arrow functions like I am, but because they're not always equivalent to normal functions, you probably don't want to use them everywhere, no matter how tempting it might be. This has been Arrow Functions, an introduction. Thank you very much for watching it. I'm Alex Booker.